Hello, I am Dr. Deepthi and we are talking about physics relevant for artists. At a very young age, we are introduced to rhythm. It could be simply by tapping your feet or listening to your heartbeat. The simplest musical sound is some kind of rhythmical beating. It stresses beat over melody and may in fact include no melody at all. Anyone can immediately play it at some level, even with no training. What are pure tones? Pure tones are sounds with a constant pitch. If you whistle very gently, it sounds like a flute playing a single note. But that single note is not a song, not even a melody or harmony. Then how do we create music? If you wish to make the single tone of your whistle into a musical sound, you need to vary it in some way. So you could either change the way you hold your mouth and whistle again, this time at a different pitch. Going back and forth between these two tones may produce a musical sequence. You could whistle one pitch in 1 second and then another pitch in following 2-3 seconds. You could keep on repeating this pattern over and over. This would make your tune more interesting. In fact, you can also ask one of your friends to whistle with you with a different pitch. Now, simultaneously, you could bang on a length of wood or pluck a fiber or blow across an open bamboo tube. Adding more pieces with different lengths and tensions, in the case of a fiber, would give additional tones. If you want to have the sound of your instrument combine well with the sound of other instruments, you would have to agree on a collection of common pitches, namely musical scales. Sound is all about vibrations. To make a sound, something has to vibrate, whether that's the string of a guitar, the larynx, that is voice box of a person, or the loudspeakers of your radio. We hear sounds because the vibrations in the air cause our eardrums to vibrate, and these vibrations are converted into nerve signals that are sent to our brains. Similarly, microphones detect vibrations in the air and convert them into electrical signals. The particles that vibrate as part of a sound wave move back and forth along the axis along which the sound wave is traveling. This movement creates areas where particles are more bunched up. In terms of physics, these are areas of high pressure or compressions. And areas where particles are more spread out, that is, in terms of physics, areas of low pressure or rarefactions. This type of a wave is called a longitudinal wave.